Today we're going to be talking about the Linux client features. They rearranged the schedule so the discussion about QUIC driver will be happening after this talk instead of before. But after this talk, we also have a talk on demystifying the complex mount options. So I think Sham and Broth, you guys are following this. Okay, so let's talk a little bit about the Linux client status. Very exciting year. Just a reminder, I work for Microsoft, but these are not Microsoft opinions, these are mine. I'm the author and maintainer of the Linux cifs client. Jim McDonough and I years ago did the net utility, so kind of a fun thing to look back in history and all this. I'm going to talk a little bit about overview of Linux file system activity, then recent kernel server improvements I'm briefly going to talk about. Obviously this is a talk about the client, but Namjay couldn't be here, so I wanted to make sure that I touched on that a little bit because sometimes people have questions about that and they come through the same trees. So we'll also talk about what's coming soon, what's next, and also some testing improvements at the end. Now to give you guys, let's see, I want to see if I can avoid this auto moving. But okay, so to give you a little bit of context, the 6.11 kernel came out 2 days ago, and it's no longer RC7. A year ago, this was the 6.5 kernel. Linus likes cool names. 41,000 files changed, 4 million insertions in a year. This is pretty darn impressive. It's a crazy year, right? Now, the File System Summit, I think, Chuck, you were there, and maybe some of you other guys were there at the File System Summit. Salt Lake City this year, a lot of talented developers. Some of them you'll see here. Unfortunately, because of a conflict in timing with other Linux events, many of the key Linux developers couldn't be here because there's other things going on in Europe this week, other open source events. Okay, so let's talk about some things that were mentioned briefly. Some of these came up in the FS Summit, some in emails, but obviously there was a lot of discussion at the File System Storage Summit about automated testing, KDevOps. We also in Microsoft have this thing called Lisa that's, you know, things like the build bot and older ways are, anyway, so there was a lot of discussion about automated testing. Obviously NetFS and folios and the variable size pages and FS cache, page caching, all that, there were multiple talks about that. Improvements to SADX has been talked about in the past. ID mount, fine-grained timestamps was talked about. I think Jeff Layton's been working on some things there. There was a rather controversial set of discussions about how to move Linux kernel drivers and file systems to Rust. And you probably saw some of that in the trade press. The mount API extensions and finish up with the conversion to the new mount API was discussed. The move to large block sizes. And a whole lot of discussion about how to leverage eBPF and dynamic tracing for these incredibly science fiction-like roles. So the eBPF guys are co-located with the storage and block people, file system people, and Linux in these events. And what is possible today is insane. It's amazing. Another thing that was talked about was obviously this idea of extending in-kernel encryption. You have the TLS handshakes for NFS and QUIC for SMB, possibilities of helping each other there. And of course, the bigger picture here is we have the shift to cloud, which can make very long latencies, and we also have very fast storage, like the Chelsea IU you see outside. With RDMA, you have like literally 3 orders of magnitude or 4 orders of magnitude difference in performance, which can cause a huge number of bugs and performance features to deal with. Okay, what about file system activity? I want to give you a quick summary of that for those who aren't familiar with it. 9660, that's huge. Change sets came in the last year. 11% of the kernel code, that's double the percentage of last year. So there was a huge increase in file system activity in Linux this last year. But only 4.4% of the code, but yet it had a much higher percentage in change sets. So lots of attention focuses on file systems. I get automated emails from bots and from lots of people scanning code. They could be students in China. They could be, Intel bots. I get all kinds of useful info. File systems are analyzed heavily. Lots of development attention on file systems. File systems in total are 1.1 million lines of code. But then again, I'm staring here. You got Jeremy and Metz. Samba's a tiny bit bigger, 4 times bigger. So I don't know. 1 million lines seems like a lot until you look at other projects. Okay, lots of progress. ksmbd is no longer experimental as of 6.6. There's a lot of drama around the bcache FS file system, which was added in 6.7. and then the removal of the NTFS file system in 6.9, and then marking riserfs obsolete. So, obviously there can be some drama about this, but there is lots of exciting work going on, and bcachefs is getting an insane, huge number of changes. Okay, so new file systems, bcachefs, it was merged in 6.7, combines various features, ext4 features, advanced ZFS-like features, btrf copy on write, integrated volume management, lots of cool features. And unlike ZFS, it's GPL. So it can be merged in the kernel, unlike ZFS. So there's been a lot of attention with a huge number of change sets ever released on this. Their maintainers emphasize copy on write, full metadata, data checksumming, replication, advanced caching, data placement, snapshots, all that stuff for erasure coding. So just a general point, these are kind of things that get a lot of attention from file system developers. But let's take a look at actually what generated the most changes. Obviously bcachefs because it's new, huge number. But as usual, btrfs leads the pack otherwise, and xfs next. Then you drop down to the ext4 and f2, whatever. Now, one of the problems has been that Namjay had to do a lot of things relating to NTFS at the same time while he's doing things on ksmbd, so it's like sucking his time a little bit. And a couple of the other maintainers moved on to other things. So on the non-local file systems, SMB as usual, similar in past years, had the most, 333 change sets. Then you have the NFS client and the various other things, ksmbd, ceph. But it's been a very active year for file systems. Okay, on the SMB client, similar activity to last year, 333 change sets. Due to code cleanup, the module's actually smaller. And we're hoping that, with some of the work to clean up, common code and RDMA and things, maybe shrink a little bit more. There's a lot of cleanup stuff we get. ksmbd is now 27K lines of code. Then that doesn't count all the user space helpers. Samba server, though, just released just last week, right? Just released its 4.21 and is over 4 million lines of code. So it's huge, this world we live in. But what are the goals? The goal is that SMB3.1.1 is just the general purpose way, whether you're accessing Brad's Mac stuff or whether you're accessing some 20-year-old appliance or whether you're accessing some brand new Samba server or the largest server in the world, Azure XSMB, or whether you're accessing, some Windows devices or the things you see in the test event, lots and lots of, you go down to the test room down there, the test event, and there's a huge number of servers and client implementations. But we have to support more POSIX-like features because it keeps growing, unfortunately. So does that mean new POSIX extensions? We had that discussion Monday. Does it mean new FSCTLs? One of the things we have to do is use the standard file system test suite to identify more features that we need to emulate. Because realistically, no human can catch up with this. There's no single person that understands all the syscalls that are added. And so as Linux keeps evolving, we have to keep. One of the things I forgot, for example, to ask the Samba guys yesterday was their support for the globally unique identifier for a file system volume. There's a query info level that gives you the UUID for target. Okay, Windows supports it, Samba doesn't, okay? Like I forgot to ask the Samba guys about this yesterday. Every year, every month, new stuff comes out. A lot of times it's already in the protocol. So, why do we have to deal with this? Well, new syscalls. Okay, this is last year, right? We added 5 new things, right? The reason I was talking about that example of the get info level was get FSUUID. Get FSUUID to support that. I could do it to Windows, but I can't do it to Samba because it needs an info level, right? Okay. But, stat mount, list mount, and then kind of along the lines of something Jeremy's brought up year after year after year, symlinks are dangerous, path-based calls are dangerous. Obviously, lots of attention on things like fchmod at. You want to be doing things that are not path-based, if possible, to avoid security risks. And of course, lots of attention on folios and those changes that have been going on. Huge number over the last 3 releases. Okay, what happened 2 days ago? 6.11 kernel came out. Surely nothing new came out in 6.11, right? I'm a maintainer, I should know this, right? Then I look at LWN and I'm like, oh my God, I've missed some stuff, I gotta add a slide. Okay, we have a new syscall, uretprobe. IOU ring now has changed. Executable files can now be written to. atomic writes possible at the block level. They added new process namespace ioctls. I had forgotten all this stuff was added. StatX was changed. You now can have null paths in StatX. The permission checks by open by handle changed. And they extended list mount and stat mount, which I mentioned earlier. I had missed all of this, and it came out 2 days ago. This was literally 2 days ago what came out. And of course, it's great, compressed and immutable. Now we were able to get these flags added to the VFS attributes, the attributes, the extended attributes that a file can report. And it's nice to see other file systems supporting that, not just SMB. But I guess my point here is that Linux is evolving, we have to evolve, whether that's at the protocol level or emulations. But we have an advantage. Lots of smart people downstairs doing interop testing. The test labs continues to be located here. I wish we should be able to do multiple events each year. I think hopefully in the future we'll be trying to bump it up, an event or two, so we can continue this really active testing. But then things get strange. Any of you guys deal with AI? So I made the mistake of asking a question about the Plugfest. I wanted to know something about the Plugfest schedule, and I made a mistake. I asked in the browser a question about, I don't know, the SMB3 Plugfest schedule or something, I don't know. Do you see what happened? This is depressing, this kind of thing that happens. AI knows more than us. So it tells me this on the side. So on the left, it brings up the link I want. On the right, it just populates this for some random reasons. It tells me that, like a loyal friend who never cancels plans, you can count on this test event. And guess what? There's more to come. This Linux client that I wrote, it doesn't know that I wrote it, is like an overachieving student who raises her hand and says, wait, there's extra credit, there's extra credit. I can work with Volker, sign me up, expect even shinier features when Volker and I get that patch done, or Paolo and I get that patch done. Now let's talk the Plugfest. This Plugfest downstairs, and remember, all I asked was like the schedule, and it puts all of this on the right. The Plugfest is a tech play date, where devices gather together to test their compatibility. SNIA, Storage Network Industry, it sets the stage here, and participants like us, like eager lab partners, work together to define testing progress. Objectives accomplished. So whether you're an aficionado or just curious about the inner workings of data highways, keep an eye on that test event there. It's the road less traveled, but as Metz would tell you and Jeremy, it's oh so interesting. Like, what the world? All I asked was the schedule. And by the way, the schedule changed too, which was bad. But anyway, I was thinking, like, we live in this crazy world of AI, but I guess I'm an overachieving student. Okay, so let's briefly talk about ksmbd. I don't want to waste a lot of time on this. You can look at the slides later. Obviously, what was it set for? SMB2.1 or later, none of the old insecure stuff. It was meant for easy to develop things, maybe RDMA, perf things. Originally, it was used by Samsung, those on embedded devices with small memory footprint. It's used apparently by lots of open source projects, OpenWRT, DDW3, but they're small embedded projects, and then some network cameras and smart wristbands and things. So at least 3 distros support it. I don't want to dwell on it, but one of the things that happened is when we added the kernel server, Linus, a few months later, or a year later, asked that we move this to a more sane directory name. So if you're looking for source code, it's no longer in fscifs. As of a year-ish ago, it's in FSSMB. There's a client directory, a server directory, and a common directory. So if you have user space libraries like RDMA stuff or compression stuff or, I don't know, some compression algorithms or crypto algorithms that are common, they belong in FSSMB common. We can use them from user space if we want, but there's a server directory and a client directory. It's a little more intuitive. You can see the names changed. But in case you're looking for the code, just a reminder that changed a little over a year ago. It's no longer considered experimental. There was a huge amount of security stuff that happened as a result of fuzzing a year or 2 ago. Namjae and those 3 guys addressed it pretty quickly. Direct releases are now supported. You can use SMB Torture to show it if you want. you have to enable SMB leases in the comp file. That's useful for metadata performance. There's a plan to enable it. So after more testing with cifs, they plan to enable it. But as a warning, we discovered a problem. Ronnie had done this service called a laundromat that sits in the background on the client to clean up directory leases. Similar to NFS with delegations, there was worries that you could have too many delegations or leases that you keep open. So this laundromat thread was designed to clean those up. Well, there turned out to be an unmount race that could cause oopses with entry freeing and the laundromat cleanup. Until we were 1,000% sure that would never happen again, he wanted to leave this off in case Linux to Linux workloads ran into that client bug. But that's something we'll be checking here again this week. Durable handle is very important for reliability, obviously durable handle support. They support the basics of Unix extensions, so when you mount with this, it fills in the SIDs as it's supposed to. It supports the create context, the negotiate context. It supports the query fs info and the query file info. And it has some of the same kind of problems with special files that we talked about with Samba yesterday. Okay, so SMB Direct fully supports it. We were very excited about the idea that Ralph mentioned yesterday to take the code out of the long Lee code that was written for the cifs driver and then the stuff Namjay wrote for the server and put it in a common directory that everybody in Samba could use. But it is very exciting, this support for RDMA. Tom Talpe was doing some testing of that recently. We did have a few bugs in RDMA that were fixed a few weeks ago, so we do need to improve the testing or at least make it more regular. It auto-detects RDMA without special configuration. Here's some interesting performance numbers. You can, if you're curious about performance numbers, you can look at it afterwards, with SMB Direct, without SMB Direct. Some kind of exciting perf numbers. Also note that to avoid confusion with Samba, they renamed SMBconf to ksmbd. Even though they tried to use similar format to make it easier for users, they did want to make sure the file didn't get confused. Man pages have been added. They, various parameters for enabling durable handles, SMB encryption, et cetera. And maximum credits have been added. Okay, currently, so got some feedback from Namjay yesterday. He wasn't able to attend. He did mention that currently, right now, one of the things he's working, partly because of the things that were discussed yesterday, was making sure the symlink, because right now he returns access denied if there's a local symlink. A local symlink is reported to causes access denied. So special file support, he's had a lot of requests from users to support server-side symlinks, and I guess this is for like shared NFS SMB exports. And so one of the things he wants to do is make sure that he reports them without the access denied today. Also, he's very interested in the talk I'm going to give you next about the QUIC driver and working with Xinlong and the other 3 Red Hat people who are working on that new kernel driver for QUIC. And also for durable handles, making sure the replay operations work well. SMB has some amazing reliability features for reconnect, and we've been gradually putting them in. Sham and Broth have done some good work on that, for example, on the client, but making sure that we properly support all of these reconnect things is important. Okay, I didn't want to divert too long on the server, but let's talk about the client, the main part of this. Now, multi-channel. Sham, trying to hide back there, deserves a lot of thanks. There were a huge number of fixes for reconnect and performance improvements, improved channel allocation, improved channel selection, what happens when you disable multi-channel on the fly, automatically detecting all these kinds of things. We plan to enable multi-channel by default pretty soon. One of the problems we've been a little bit worried about is today, unlike Apple and unlike Windows, we do our connections to multiple channels sort of synchronously. So mount can take, what, a few minutes sometimes? Is that reasonable? So there are times when it just takes a little bit longer because you can, for example, my home machine, my home Windows machine advertises Hyper-V interface, which is not reachable. But when I see a query interfaces, I see this as the top, so it tries to connect to an interface that's not there. So one of the things that we have to be careful about is making sure that we do this asynchronously so we don't slow down when so we don't want a multi-channel mount to be slower than a non-multi-channel mount. So there's a few minor things, but I think enabling it by default, we've been testing it literally for multiple years, and the test results for multi-channel look excellent, and obviously it provides huge performance benefits, so we don't want to lose that. that advantage. And as you probably know, what multi-channel gives you is we mount to the server, but we detect whether RSS is supported and it's worth creating multiple connections to improve performance. And if it has multiple adapters, we'll connect across multiple adapters to spread I/O and to avoid network latencies causing performance issues. Even if there's only one adapter, with RSS, it's significantly faster to have two connections. And it's beautiful that in the SMB world, we can auto-query interface changes and be able to dynamically adjust. There were some fantastic demos 5 or 10 years ago at SDC showing the performance effects on database benchmarks and things like that of just literally putting an adapter in, watching the performance double. Removing an adapter cuts it in half. Putting a faster adapter in, it goes up 10 times. It's all auto-detected, which is beautiful. Okay, directory caching. We have a new module parameter, dir cache timeout. Max cache throws and handle timeout are available at mount time. It allows you, one of the problems we have is that for directory caching, we don't really know what the optimal numbers are for each type of server. So we made these tunables to allow developers to kind of experiment, and then we'll dynamically start setting these in the future when we understand better values. But in the meantime, we tended to be fairly conservative about how many directories we allowed to be open. But this provides enormous metadata caching improvement. So direct releases matter. And I was extremely excited to see that German grant that Ralph was talking about yesterday included support for Samba adding direct release support, not just Windows and ksmbd. Okay, special file support. So Paolo did some additions for special file support, which is good. We had some feedback today in the emails that I think, Paolo, you got a patch in progress for some of that. He added a new mount parm reparse that lets you choose which reparse type. There's two that Windows frequently used. Used to be the NFS format, now the WSL format. WSL has fewer round trips, but you know, there's an email discussion about that going on right now. This allows us to better handle special files, FIFOs, symlinks, and well, especially block and character. Symlinks, there are multiple ways we can handle. There's been an obsession on security. Security waves everywhere, right? And one of the things about the security obsession has been you cannot just leave passwords for days or months. You have to rotate them. Well, how do we do that? Today, if you change your password on the server and the network goes down for a half a second, your mount's unusable. You have to unmount and mount again, which isn't very good, right? Because you unmount and mount again, you might fail because you have open files. So Azure, as a server, has already supported this idea of rotating keys and multiple passwords. So, sorry about that. So we now allow you, so it's becoming a common requirement that you have to rotate these. But what we didn't allow you to do was change the password on a live mount. Now we do. And in many cases, you also have to have support for two passwords, because your passwords will rotate kind of in series. You know, one will rotate tomorrow, one will rotate a week from tomorrow. So if you had two mounts of the same server, one with key 1 and one with key 2, you change the first one, not the second. The first will be inaccessible. Before this, it would require an unmount, then a mount again, and your debug data would show disconnected. You can see this, right, the disconnected. With the change, now you can update it on the active mount. So here we have a remount with the new password. So it's in the 6.9 kernel, but it was backported to 6.8 and 6.6 kernels, and probably by some of the distros as well. This is a very important kind of thing. But notice here that we were able to remount even though the password had expired by specifying a new password. That makes it much easier to rotate passwords. And remount of a working mount with a new changed password is not permitted. But if the server had returned e-access or e-key expired and the session is down, so we wanted to create a way that, okay, let's say that you want to add a new password for the mount, but your current one's still working. We allow an alternate password. So you can have password 2. So if you have a working mount that you know is going to expire soon, but it's not dead yet, you can add your alternate password, password 2, and it'll automatically change over to the new password when. So here's a summary of the features. changing a password before required unmount, then mount again, which wasn't always practical if you had open files. Now you can change the password on remount if the server is not connected, or you can add a second password to the mount if your session is still alive. And the cifs.creds approach, which leverages the kernel keyring to save the passwords, would have been the logical way to do this. And we talked with David Howells, the maintainer of cifs.creds, a lot. Unfortunately, the cifs.creds approach, where you have the kernel store these in the kernel creds keyring, wouldn't work because the process that's doing the reconnect is not a child of the mount process. So you really couldn't save them in the kernel keyring. If somebody has ideas on how to, so David was wondering kind of like a better design for the kernel keyring so we could do in some way to save these in the kernel and have the kernel keyring manage these. But until the kernel keyring changes, there's no real way to find the key when you're not the child of the mount process. Anyway, so the ability to remount with the updated passwords in 6.9, and it's been backported to 6.8 and 6.6. Yes, go ahead.
But when you do Kerberos and reconnect, the thread doing the reconnect is not
Yes. So his point was when you're doing Kerberos, the thread doing the reconnect is not the one. Okay, good point. And unfortunately, that's also something that Sham and Broth have been talking about. There can be cases where the namespace of the process that's looking for the key, in the Kerberos case, we don't have to get a new password, we just look for a new service ticket. In the Kerberos case, it's different because we can have a problem with namespaces where the Kerberos cache that we're looking in isn't compatible. If we're in a different namespace than the guy that did the mount, let's say a containers example. So that's something that Sham and Broth, I think you talked with Metz about and some others, right? Yeah. So one of the points that Sham made was the key type, is different for these, so that makes a difference. Also, it's a little bit easier to find the keys in the multi-user Kerberos case. A little bit easier to find. But this is one of the areas that's extremely important to work through and is probably not the only case that we have to deal with. We're different namespaces. And remember, in Linux, we have process namespaces and we have PID namespaces, we have mount namespaces, we have network namespaces. And it gets extremely confusing trying to see how that would impact what MIT Kerberos or what Heimdall Kerberos uses for stashing away keys. But it is a slightly different problem, but it's an extremely high priority problem in this world of containers. And obviously, Paolo, Barath, Sham, and others, this is very, very important work that they're looking into. Okay, so one of the things that has gotten a lot of attention is the redesign of the page cache. As you know, it's not just IOU ring, it's also folios, variable size pages. You can look at LWN articles. They're also moving to larger block sizes. Great stuff. A lot of this is due to David Howells, who unfortunately also maintains the keyring, so he keeps busy. But he's been working with Christian Bronner and many of the VFS people on these improvements. Moving it out of individual file systems into the NetFS layer sounds great, but we had regressions in 6.9, we had regressions in 6.10, and we had regressions in 6.11. Now, fortunately, we chased them pretty much all down before the releases came out, but then, 6.10 comes out, more regressions. Well, guess what? 6.11 came out 2 days ago. Guess what I was staying up till 2 in the morning doing? Presentation? No. Staying up till 2 in the morning working on talking with David Howells, right, about these fixes. So it's great, and he's been very responsive. But one of the things we have to be, and by the way, it's a good thing, right? So FS stress, for example, common agnostic files test, right? 5 to 10% faster now. It's awesome. I'm super happy that we parallelize I/O better. This changes to the page cache has been a great performance benefit. And by the way, more testing is needed. We may find weird corner cases where we have to get bug fixes from David. But we have to test obsessively. And so literally, a few minutes before I started the presentation, guess what I did? Started some more tests. Anyway, fortunately, the 3 regressions that happened yesterday, or the, day before, yeah, whatever it was, the first merge request Linus did was the VFS stuff. 2 of them were fixed. 3 were fixed really fast. So we're down to 1. But the good news is interleaving local reads, local caching servers, write caching can be done better, lots of performance to the read paths, FS stress 5 to 10% faster, and the support for variable size pages, and this is fantastic stuff. I'm excited about it. What I want to get more obsessive about is testing. And so one of the suggestions we had, as you know, NFS and SMB are tested automatically for stable. NFS or SMB are automatic. I get bug reports about stuff and automated testing. Unfortunately, what we need to do is also automate test the VFS next branch, not just my next branch, not just Chuck's next branch, not just Tron's next branch. So we also need to be automated testing various file system specific things in Christian Bronner's branch. So hopefully with that testing, we won't have this nightmare of staying up till 3 in the morning before a presentation. Okay, so let's, so in the 6.10 kernel, lots of stuff. In the 6.11 kernel, lots of stuff. And another 9 cifs patches already for this in 6.11, or sorry, 6.12. One of the things he's working on now is finding ways to do content crypto inside the NetFS layer. Now, POSIX extensions. We had a good discussion about this Monday. The basic features are all working. We have some server-side symlinks problems on the ksmbd side. The mode bits report okay. The owner report's okay. There's a query fs info that they have a fix for, but it's being tested. We're doing more testing here. Multiple servers and multiple clients supported. So ksmbd, Samba, it looks good. So here's an example mounted to Samba on the left, an example mounted to ksmbd on the right. You can see mode bits, case sensitivity, lots of useful things that literally you avoid getting the data out of the wrong file. Case sensitivity, you get the mode bits right, you get the owner right. Statfs works better, stat works better, that's all awesome. And without these POSIX extensions, you can have problems with delete. You can see an example here of problems with delete. It stays in the namespace. Okay, here's an example of rename and delete of open files to ksmbd. Makes it a lot easier on the server to write these POSIX extensions. But we do have things working through. Ralph did a great job, a year ago actually, creating these documents. One focused on the protocol frames, one focused on the behaviors, the FSA. The FSA needs a lot more stuff, but this is a fantastic start. Maybe we can have a link to it from the SNIA site. But this Git project allows you to easily build the PDF or HTML for the documentation. They're quite small. The number of protocol changes are basically 2 info levels and 2 contexts. So it's not bad. Here's an example of what the HTML format looks like. Okay, so I don't want to spend a lot of time on this, but I wanted to make sure that this data was available if you want to look at it later. We also have a website with this on. It kind of gives you a rough idea of what was included per release in the new features. Obviously, deferred close performance improvements was huge. Lots of DFS namespace fixes in 6.6, thanks to the global namespace, thanks Paolo. That reparse point stuff. We added that max cache jurors to control how many direct releases. The dir cache timeout thing was added. Lots of important reconnect things from Sham and others on the 6.7 kernel. We added some useful debugging stuff, being able to get the tree connect info and the session ID and treecon from the mount helps you correlate which mount point is which debug thing or which mount point is which stats. So that's kind of a cool little thing you can do with SMB info now. I think Anthony Ananda did the patch for SMB info to use that. Lots of fallocate improvements. And then 6.7 kernel, what really caught me off guard? What if you got an email from an MIT email address? What would you think? Yeah, you think it was Ted So, right. And Ted So, really nice guy, ext4 maintainer, used to be a Kerberos maintainer. And you're like, that's not Ted. Is it somebody, is it a student? Oh, it must be some student. Some student must be working on a grad project or something. Okay. So I get this email, and I'm like, that name's... So I look him up on LinkedIn, and I'm like, oh, he invented the computer virus. I got a bunch of, hang on, do I trust a guy who invented the computer virus? You know, you heard about the XZ compression vulnerability, right? And you're thinking, should I trust a guy who invented the computer virus? And then I look at it and like, oh my gosh, this is amazing. I have no idea exactly how he did this, but he created fuzzing test cases that were genius, showing possible out-of-bounds fixes. And so Paolo and I fixed a bunch of these, and it was utterly amazing. And I'm like, I felt like, you know, here's a guy who, I guess it's a felony, right, to do this, becomes an MIT professor, brilliant genius guy, creates these incredible test cases showing out-of-bounds things with this advanced fuzzing. And we open source people benefit from this because he finds possible security bugs that were really subtle. Anyway, it made me very happy that people are analyzing the cifs code, the ksmbd code, open source code in general in the kernel. They're analyzing it carefully, and it helps make our life safer because this community finding things like this makes everybody's work more secure. SMB is an incredibly secure protocol, not just the encryption, not just the authentication options. But I was very pleased. 6.8 kernel, we have some new mount options, retrans, special file handling improvements, lots of useful stuff. You can look at this later. 6.9 kernel had some, you know, the remount thing we talked about. Improvements to delete of open files and metadata caching. 6.10, some important folio stuff. We re-enabled swap files, which had gotten disabled earlier the previous year. We added various dynamic trace points to make things easier and did some important RDMA fixes and folios fixes in 6.11. In 6.12 merge window so far, and it's only been 3 days, we already have 9 or 10 patches that have been merged from other trees. We've added partial support for SMB3.1.1 compression. We're not as far along as Brad was, but it's an exciting thing supporting compression. So it's still experimental, you know, don't use it in production yet, but there's a mount option to use compression if you turn on this experimental config option. SFU has some improvements. We've got a couple other bug fixes. Paolo's working on one right now. Some of the special file stuff we talked about. Actually, the SFU was the Debian guy, but the special files fix was Paolo was looking at. These NetFS improvements we talked about. And then there's a lot more expected due to discussions and testing this week. An example of this was the OTemp file stuff. We added some incredible improvements to tracing. Also, we talked about you can now display the client GUID, the server capabilities, the network namespace. The link speed is now shown properly. Last year, well, a little over a year ago, we had 100 dynamic trace points. Now you have 127. So if you individually want to turn on and create these fancy scripts, it's as simple as, you know, trace CMD, record, you know, SMB3, make dir error, right? So 27 more trace points. And basically what we want is if you have a problem, we want you to let us know what would make it easier to trace the problem. We see this from David Howells, for example. David Howells is trying to trace some crediting issue, reconnect crediting mismatch in the NetFS that's broken cifs, right? We want to add more trace points. So you as developers, when you're debugging a customer problem or you're debugging some bug, if there's a trace point missing, let's add it because these are like zero cost. They don't cost anything when they're turned off. And the beauty of this is it allows you to selectively enable what matters to you as your, in the examples of this is looking at slow responses. Now, what's some work in progress? So at the test event, we're looking at the compression support. Jun Ma had helped with an early version of support for OTemp file. We're looking at that. One of the things that we've been talking to is improving our Mac OS interoperability because there's 1 or 2 Macs out there. I think, Brad, you said that there's 1 or 2 Macs that use SMB. Maybe a few billion cell phones, or how many? It's like crazy. Like when you think about this, it actually matters, and it's something we put off for a while. Improving the content crypto, a great idea that Dave Howells has been investigating. And then one of the things that's an extremely high priority is supporting additional auth mechanisms because we need to move away from NTLMv2. And one of the things that we're going to try to do as a priority is not just things for Azure, not just things for Samba, but also the Windows new auth mechanisms. And actually, Apple has 2 auth mechanisms, or 3, I guess. It's got the peer-to-peer Kerberos that Apple supports. We want to move away from using NTLMv2 ever, if we can, And that means we have to support what Apple supports, we have to support what Windows supports, and what Azure supports. And so these new mechanisms, hopefully we can rely on mostly upcalling to user space and maybe borrowing some Samba code to do this better. But what we don't want to do is have to make complex auth code in kernel. So one of the things we're focused on is not just upcalling for traditional Kerberos, but also for these other new mechanisms and finding ways to support new auth mechanisms as they're required. And obviously, from a Linux client, there's at least 3 that we can think of immediately that are required. So we can deprecate NTLMV2. There are many cases where Kerberos is way better, but what we found in practice is that many, many customers don't want to join Active Directory or Samba Active Directory. Many customers just don't want to do that. And so Kerberos sounds wonderful, but the peer-to-peer Kerberos or the IA Kerb, these other things are required. So it's a big focus, and it's an area where we're going to need a lot of help. But there's also things that may be able to be leveraged from other projects. Okay, our goal is to release 7.1 this week. The only thing that held me up from releasing the 7.1 kernel, to be honest, was checking a couple mount page things that Bharath had been working on just to make sure we have the important stuff in. The second, we're comfortable because the man page was somewhat outdated. But there's some good things like the CLDAP ping stuff to find the closest site. This improved debugging, I mentioned the SMB get con info, so we can correlate stats with which mount point it is. So if you have multiple mounts to the same server, you know which one's which. And then updating this documentation. There are also various new tools being considered. There's some amazing debug tools that I think Bharath is going to talk about tomorrow, right? And so some of these debug tools are worth listening to. But what we want to do is be very open to adding any tool, whether it's for debugging, whether it's to make mount easier, whether it's to improve how easy it is to mount snapshots, whether it's for whatever. The point is that tools that leverage existing FSCTLs or tools that make it easier to use SMB mounts, we should be adding to cifs.utils. We haven't been doing enough updates recently. We did a lot of activity up till like 2 years ago. We need to increase that. But the number one most important thing we need to do is get obsessive about testing. We run hundreds of different tests, not just this XFS test, but also Git functional tests. And we have our own, you can see the cifs.01 and some other CIF-specific tests. We run it to a wide variety of servers. Samba with the VFS, BTRFS plugin, Windows, Azure with multi-channel, the POSIX extensions. We're going to try to redesign this to make sure we run against more current Samba with POSIX extensions turned on, for example, and also do things if we can, I don't know how to do this, but maybe someday we could add Mac and Netapp and other targets. Because what we want to do is make sure that no server, that we don't want to arrest any server. So getting obsessive about testing, our testing is very public, right? So you can see what we run. Now, realistically, Red Hat and SUSE and others do better testing internally. And we're working on some things inside Microsoft to leverage Lisa that may even help even more. But our goal here is to run with a wide variety of configurations and quickly detect things. And the exits for these tests also look for things like reconnect. They also look for things like log messages, KSAN things that might be indications that the test had some problem, even though the app worked. But the test, we still are going to say it's failed because of something that was logged. So obviously, there's lots we can do, but I do want to make sure that we get obsessive about this. And what that also means is maybe learning from projects like the Samba project. When you send a patch for a fix, we'd love to also send a test, whether that's upstream to XFS test or that's a private test we add. I think we need to be very obsessive about this. And also, we know that it's run with stable, we know that it's run with various distros, but obviously, the more variations, the better. And we also keep a wiki page that we're trying to keep updated with the test. And also, I think we'll post a script that we have that, for the command line can run all the tests you want. So based on the server type, if you're running to Windows, run these 200 tests. If you run to Azure, run these 100 tests. If you run to Samba, run these 100 tests. And we want to be able to auto-run tests against branches like that, Christian's branch. And obviously, we welcome new tests. This is extremely important, and I don't want to underestimate that. If you want additional resources on this, there's lots of useful things. Obviously, the protocol documentation, SMB3, the source code, whether you're talking about Samba or whether you're talking about ksmbd or cifs, the source code's fairly easy to find. Also, the mailing list. Samba technical mailing list has lots of useful information, the Linux cifs mailing list. Also, there's various presentations available for both sambaxp.org and then this conference here. I, for example, found a wonderful presentation on Wireshark that helped recently, but I also found things useful on replay detection from previous conferences here, and also things that were extremely useful about RDMA here. So remember the archives. Lots of great presentations over the last 10 years. Okay, we have 2 pull requests pending for Linus, so if today works out well, we might have another 30-ish patches ready to test when we finish this. But I've had to race through to make the time, and I think we've got maybe 1 or 2 minutes left for a question or two. But does anybody have any short questions? Anything interesting? So a couple quick things to mention. Following this, we have a presentation here, and then I'll be going to another room to do the presentation on SMB3.1.1 over QUIC, so those will be recorded. So if you miss one, you can look at the other. Tomorrow, we have at least 1 or 2 SMB talks tomorrow. Sounds useful. We very much welcome any contributions or suggestions you have, and this is an incredibly exciting time for SMB. Even if you don't count that AI bizarre response that we got, it's an incredibly time. And so I'm getting extra credit, I hope. We do lots of patches this week, and you know, I also look forward to things that you might prioritize, so we can understand, you know, how to prioritize, because there's a lot of little things that we can continue to improve. One of the things that people forget is the SMB protocol is literally 10 times bigger than most people know, and we only implement like 20 or 30% of it. There's an enormous set of features that we could implement on the client that could help narrow Linux cases. Anyway, thank you very much for your time, and question for you. So access control. So the question was, is access control done in the ksmbd module? The short answer is, yeah. The exchange of ACLs between client and server. So yes, both Samba and ksmbd support exchanging ACLs over the wire. There are tools like getcifs.ko and setcifs.ko that support this. One of the questions that's very controversial, I think Chuck can tell you more about it, is there's been pushback on supporting ACLs in Linux. Linux supports a very very narrow ACL model, right? I mean, realistically, they're not POSIX, and they don't have any deny aces, right? And they're much less rich than any other. I mean, they're the most primitive ACLs imaginable. One of the things we thought about is it worth just emulating it? In SMB1, we had support over the wire for those POSIX ACLs. We decided in SMB3.1.1, we'll just use the rich ACLs. And NFS did the same thing. But there is some pressure on NFS, I think, to support the kind of dumber ACL model. I don't know how that's going to play out. But in the short term, yes, ACL is going to go over the wire, and yes, you can set ACLs and get ACLs. And I think for both NFS and SMB, there's a private API for that, and we could make that a common API if we want. There's plenty of test cases to test that inside XFS tests, so it's not like it's hard. Yes. So MSRPC. So yes, we generally rely on Winbind for most of those things. That I think that's a good, somewhat tricky question, because the MSRPC is only needed for a few calls, but there are a few places. For ksmbd, it's a slightly different story than obviously the client code. But in general, the thinking that Namjay had about on the server side for MSRPC, whether, you know, how to use that, was that it was better, where possible, to let Samba well-tested user space code do things for ksmbd, then it was better to add kernel code or kernel helpers. So where possible, the goal originally was, if Samba had code that the kernel server could leverage, let's say RPC code might be an example, it's better to upcall unless it's a performance-sensitive path. I mean, does that kind of make sense? Yeah. I mean, you can run without Samba being installed, but at the same time, the goal with ksmbd was to minimize some of that kernel code. And as you said with Solaris, you know, there's a lot of things we can learn from these decisions. But there's other similar things where we want to make sure that we don't duplicate code in the kernel where we can use user space code. And the same thing applies, by the way, to my next talk on QUIC, which I have to head over to. Once again, if we can do user space code for things that aren't performance sensitive, it's way better. Okay, thank you for your time.